Hi. Today, I'd like to discuss the most important subject in all of Eurorack: how to plug a module incorrectly. This video comes out of the fact that I just destroyed a Eurorack module by plugging it in the wrong way round. It was a Dupfer A148 sample and hold module, and now it's a paperweight. See, I've been using Eurorack for 7 years or more now, and even I make mistakes. And you would think that Dupfer, being the founders and originators of the format, would make foolproof modules, and you'd be wrong. In fact, I would go so far as to say that Dupfer are the worst manufacturer for potential accidents. We're in the Wild West here, folks, and there are no standards. Every module has the potential to be plugged in wrong. And if it breaks, it'll be your fault. I'm going to try and cover systematically how to plug in a module safely. And at the end, we've even got a little bit of exclusive Eurorack power story time with the beautiful Ger Milstein of Tip Top Audio, whose power systems you might quite possibly own. So if you watch this video through and are careful, I intend for you never to make the same mistake I did. Firstly, the guide, then story time. But first, here's the quick guide to correctly plugging in a Eurorack module for people watching this on their phones in their studios who just want to plug in and go. What you need to do is read the manual. And if it doesn't say in the manual, ask the manufacturer to talk you through how to plug it in correctly. Don't ask on forums, don't Google it, and don't guess. Other people can get it wrong, and if you plug it in wrong, it'll probably break and it's your fault. Read the manual or ask the person who built it. If you can't wait for a response, the risk is destroying it. The end. And now, the long version. So, Eurorack modules are plugged in with ribbon cables, like these. Now, one end of the ribbon cable goes into your Eurorack module, like this, and the other end connects to the power board or ribbon connector in your case. You plug both in correctly, and you turn it on. Done, right? The troubles come from the fact that the ribbon cables have an orientation at both ends. There is a right way round at the module end, and there is a right way round at the power distribution end. And if you plug both ends in the right way, you get music and joy. But if you accidentally plug in either one of the other ends in backwards, your system lights up weird, you smell weird smoke, you hear a crack as ICs pop, and your module is dead. Step 1. Confirming the cable has been made correctly. In a minute, I'm going to tell you to ignore red stripes on the cables, but I know you're going to disobey me. So I want to make sure you do this, because cables can and do get made incorrectly, and you need to learn how to spot them. So some cables you'll see have 16-pin connectors, like these little doofers, and then some of them have like these smaller 10-pin connectors here. Now, the advice that I'm about to give you is exactly the same, so don't worry about the size of the cable. Fold over the cable so that you've lined up the connectors with each other, and look very carefully at the ends. Note the little lumpy notch. The coloured stripe should lie on the same side of the notch on both connectors. Now, most connectors have the stripe on the end that you can see here in the video, but Schweiman modules actually have the opposite. So the stripe might not be red, it might be different colours, but the point is, if you follow the connectors with your finger all the way across, and the orientations match relative to the notch, then the cable is good. If you follow with your fingers and it flips through onto the opposite side, put the cable in the bin and send a strongly worded letter to whoever sold you the cable. So once again, you're putting the heads together in the same position to make sure, relative to the notch, what starts on this side ends on the same side on the opposing end. Cable good? Good. Moving on. Step 2. Connecting the cable to the module the right way around. This is going to take a little bit of explanation, but bear with me because it's actually where things get super inconsistent between manufacturers. And it's where I made the mistake that destroyed my A148 sample and hold module. And it's also where you're going to be most likely to mess something up. So please listen carefully. Eurorack power is mostly 12 volts. And this 12 volts of power flows in through the ribbon cable, and it does it in 2 directions. There is a positive side and a negative side, and these sides are noted thusly: positive with a plus symbol and negative with a minus symbol. So there's a positive and negative side to the power output, and there's also a positive and negative input on the module. And the ultimate aim here is that when I take my finger on the module from where I know minus 12 volts is supposed to be, if I use my finger and I trace along the ribbon cable, that it leads down inside the case to the point where the minus 12 volt power comes out. I am not thinking about red stripes or anything like this. I'm looking at the module and I know where minus 12 volts is. And I'm making sure that when I trace with my fingers, they all line up so that the minus 12 volt output lines up with the minus 12 volt input. That's the aim. Not to match red stripes. Don't think about the stripes. Think about tracing with your finger. Because power doesn't understand where the red stripe is. We need to think about what's actually happening inside the cable to make sure we catch some of the scary, simple little mistakes that can happen. Because it's generally accepted as shorthand that the red stripe corresponds to minus 12 volts, but that assumes that the other end is plugged in to minus 12 volts correctly. The red stripe only means minus 12 volts if you know that minus 12 volts is actually going through that end, because it is possible to plug it in the wrong way round on certain power supplies, just as it's possible to plug it in the wrong way round on a module. And in fact, get this, on enormously expensive Schweiman modules, the red stripe doesn't mean negative 12 volts, it means positive 12 volts. This is NARM. There are no rules. And of course, what you're now thinking is, well, okay, if the most important thing is that I know where minus 12 volt is on my module, how do I work that out? That is a fantastic question, and it's one you must ask. But here's another one, which is, have you established that you actually know where the power sockets are on the module? Because in the case of this Laddick module, here I have my little cable and I'm looking for power. Hang on a minute. That is actually an expansion cable connector. So if I was to plug that into power, I'd blow my module up as well. No matter which way round I plug it in. And so usually, if you look around the back, these things are labeled. Look, expansion, it says. And down here, power. But it may not be that clear. And so the only way to be sure is check the manual to know that you're even plugging into the power port. Check the manual. And so generally power sockets will be indicated on most modules. There will be a thing that says minus 12 or red stripe or red or a little bar symbol, which is there to indicate the correct orientation and is usually what is next to a power socket. Then what you need to do is plug your power cable in a way that if you trace with your finger will lead to the corresponding positive or negative side on your power supply connector. However, for some manufacturers, and especially if you're trying to plug in a Dupfer module right now, put nothing on the module to indicate where the power input is and where the minus side of the power connector is. Or even worse, we'll put something unrelated like JP1 just to mislead you, and worse still, put nothing in the manual to indicate how to correctly find minus 12 volts. This is how I broke my A148. So for DUTFA modules, I will deeply grit my teeth and mention the mnemonic that I forgot, which is red stripe down, which is to say that the minus 12 volts is at the bottom of the module if it is stood vertically the right way up. But that mnemonic does not apply in any way meaningfully to any other manufacturer and is quite frankly bullshit, because it only applies to DUTFA and therefore can just lead to assumptive errors. For example, here's an ALN pip slope. Oh look, red stripe down you say? No mate, no. Red stripe up actually, red stripe up. So mnemonics suck, but that's the one for DUTFA modules. The bottom line here is if you're in any way unclear, you must refer to the manual or ask the manufacturer. I say again, refer to the manual or ask the manufacturer, because what you should not do is don't go on forums, don't go on Muffwiggler, don't Google it, because I have seen with delicious schadenfreude when people make the wrong assumptions on your behalf. And I've actually seen forum posts where people post back to say that they just plugged it in and it blew up the module using advice other people gave them. So don't trust anyone except the manufacturer. And I know it sucks that DUTFA don't put it in the manuals, but please write to them and please ask them to do that, because I think it's a massive oversight that they don't educate users where to plug in and how. Don't make assumptions, check the manual, because this is where errors happen. It's generally better to never disconnect the power from your module if you can avoid it, because it just introduces errors like that when you do. Step 3, plugging in to your power distribution system. So we've established that our cable is good. We've identified where the power connector is on the module, and we've identified which is the minus 12 volts end of the power connector. It's time to hook her up to power. So now if you look inside your case at the power side, you're going to have one of two different types of connectors. You're either going to have a strip like a PCB with lots of connectors on, like DUTFA bus boards, or like these MDLR boards that are in my new case, or something similar. Alternatively, you're going to have power from a power module like this, and then a flying sort of ribbon cable where you plug all your modules in. But in every single case, the thing that you connect the power to will be a 16-pin connector like this. And it will either have a shrouded header like this, which can only be plugged in one way, or if it's like the DUTFA style, it'll just be bare pins, bruv. And what we should be able to see somewhere on your power distribution origin, it should say minus 12 volts somewhere, even if in tiny little writing, so that you can establish that on the flying bus board, the red side really does run all the way to minus 12. Once you've kind of okayed your power supply and you know that the red stripe really does mean minus 12, assuming that your module is plugged in correctly, then the notches are kind of great because they're foolproof. They can only go in one way. So when you plug in the module, you know that you've married up minus 12 to minus 12. It's neat, assuming the power supply is correctly orientated. The alternative, however, is this. See, we've got bare pins where there's no shrouded headers. And of course, that means that every single time you connect, you must make sure that you are correctly orientating the cable. So you can just about see that it says minus 12 volts at the bottom. Okay, cool. Problem is when you're reaching in to try and disconnect a module and you can't really see, the chance of plugging it in backwards is very high. And also, even more insidious is the option of doing this. Like that. What I've done is I've plugged the cable in one pin too high. So if you feel at the top, check the top and bottom. If you feel a pin, you've gone too high. If you turned it on, your whole system would go weird. So it's really important to use a torch when you are plugging into one of these systems. Don't make assumptions. Unshrouded bus boards like this are a nightmare. Step 4, being ready to fail. So we did everything right, we think. And it's time to turn the modular on and check that it doesn't blow up. Now, most bus boards and most kind of flying power sources like this Tip-Top Micro Zeus have indicator lights on the modules or on the bus boards themselves, which are there to light up and show you that the positive and negative 12-volt rails and the 5-volt rails are functioning correctly. So let me just quickly mention 5-volt. This is an extra line of power running down the ribbon cables, which is used basically to run certain digital modules. And to be honest, which you don't really need to think about in terms of this whole correct orientation thing we've been talking about. All you need to know about a 5-volt is certain modules require 5 volts to work properly. And the modules say in its specs whether there is a 5-volt rating for it, meaning it needs some 5-volt. And certain supplies will supply it. Check the manuals, check the manufacturer website. It will confirm whether it supplies 5-volt as well. This Tip-Top does. Not all do, like the Dirt for ones by default don't actually supply 5-volt unless you connect the power lines accordingly. Okay, so here's the moment where we power it up. And I think the thing I just really want to communicate to you is be vigilant at this point, because this is where the potential for damage is going to occur. And if you turn off the power quick enough, then you may be okay. So what we're going to do is we're going to turn on the power, and I'm going to be looking to be sure, is the minus 12-volt lit? Is the plus 12-volt lit? Is the 5-volt, if it's there, lit happily? And you also have an eye on the rest of the system. When I'm turning it on, if these don't light, or if some of my modules don't light properly, turn it off immediately. So the turn on process is an active and not a passive experience. So fingers on the button and keeping it there. Yeah, mate, all good. Just to give you an idea of what you're looking for, when I turned on the modular and I had this in backwards, the lights didn't light up properly. They kind of half lit, and some of the modules half booted, and I smelt this module very quickly. It makes a kind of almost like petrol-y kind of acid smell. And there was just a crack, which was that TL064 splitting down the middle. Rock and roll, mate. So I think, yeah, my advice is just be mindful of these lights. If you have the Dirt for bus boards, they actually have lights on one end of the boards. Most power supply manufacturers, if not all, will put lights like this kind so that you've got a kind of warning system. If you don't see these lights, turn it off and check all your connections again. And just to say as well, with the Dirt for thing, obviously, if you haven't got 5-volt power connected to the bus board, then the 5-volt light won't light up. It's really the plus and minus 12 that we're looking at. And it's so simple. That's actually all you have to do. Every single time you power these things up. Yeah, that was maybe not very fun to watch, but that's because it's really frigging important, and it suddenly made me realize how many layers of danger there are in this whole thing and how everything is up to the user. Nothing really is necessarily given to you on a plate. So it does kind of suck. It isn't fun. And definitely we can all do with reminding of it from time to time. Even I get this wrong sometimes. And I've done that thing of having a module plugged in a little bit high so many times. We're all capable of screwing it up, and the manufacturer will not accept liability. And I know that sucks, because obviously we'd all just like to plug stuff in without a second thought, you know, like we plug in new synths into the wall sockets. But sorry, It's just not really that simple. And so we have to be well informed and armed and careful. Trace with your finger. Triple check. Don't trust cables. Don't trust red stripes. Trace with your finger from origin all the way to destination to ensure that those plus and minus 12 volts do actually line up, and triple check. And if you're in any doubt about which ports to use, what orientation to use, you shouldn't be making any assumptions. You should be checking with the manufacturer. Assumptions kill Eurorack modules. So now, story time. I've invited the beautiful Mr. Milstein of Tip Top Audio to share some thoughts as a designer manufacturer of power systems as well. He's been doing it for years. So, ladies and gentlemen, Mr. Milstein.
So imagine a car is like a module and the roads is the bus system. The roads have signs, have symbols, the cars have all kind of safety features, and the two of them interact together in a way that protect us from a crash. The bus system was built in the same manner and use things that are quite similar. As long as the signs are correctly placed and as long as the cars equal to modules are correctly made, then there shouldn't be any problems. The problem really start happening when we are changing things. Like imagine on the road, right? If we put a stop sign on the other side of the road, then it doesn't really help anymore and actually might even cause a crash. The Eurorack power connector is 16 pin. That's a standard. The lower 2 pins are -12, then 6 pins up are ground, then 2 pins up are +12 volt. And then the remaining pins are what's called a CV and gate bus, and they can be used to send CV across the bus and even audio. There's all kind of things that can be done using them. They're not that important at the moment. And of course, there's the 5 volt rail. Now, the power connectors on the module side are not always 16. Sometimes they are 10 and sometimes they are 16. The reason for that is because some modules don't need the CV and gate or the +5 volt. They only need the ±12 volt and the ground. And it makes for a smaller connector, which can make for a smaller module. It's just something that was, again, done originally when the bus was designed. And the key to make it work well is not to disconnect the power cable from the module side. Once you disconnect the power cable from the module side, you are basically now open to speculation on how to reconnect it back. If you are not familiar, highly familiar with Eurorack, there's good chance you might do the mistake right there. Add to that some modules have additional connectors on the back for different purpose, and you actually might plug in the power cable into those and you will completely burn your module. So it's very important when you pull out a module, make sure you are always disconnecting it from the bus. The bus is always 16 pin, is always oriented. All the connectors are oriented on a single plane, meaning they are all siding in one way. So it's easy to remember, oh, I know, always the red line goes here, okay? On the modules, it can be different. I saw modules that have connectors flipped completely, have the red line up, okay? There's a lot of things that can go wrong. So when you disconnect a module, unplug the cable from the bus board, not from the module. So what really happened when we burn a module through reverse powering? That means that we are probably connecting the +12 volt to a -12 volt and the -12 volt to a +12 volt. The damage is severe and module without any protection will immediately burn. And in some sensitive modules like VCOs, the damage is most likely beyond repair. Another situation that happens is that because we have two types of connectors in Eurorack, one is the 10 pin and one is the 16 pin, is that +12 volt will short to ground. So that's another situation. It's not as severe as the first one, but can cause different problems as well with nearby modules. There was a lot of criticism on the way the Eurorack busboard was designed. To a certain extent, it's true, because people need to understand it. Originally, when Eurorack started, it was really a small niche of people, and we kind of all knew what we're doing. And, you know, things were made in a way that, oh, okay, people figure it out. You know, that was kind of the way it worked. Over time, Eurorack grew up, more people come in, people don't want to become technicians, they want to stay musicians, and they don't want to deal with all that stuff. They just want to plug things in and know it's working well for them. The solution was to start making key connectors. And key connectors means that the socket where you plug in your power cable have a little notch, and it basically doesn't let you connect things in the wrong way. So the first thing I would recommend people is that if they are new to Eurorack, they're coming into this thing, then make sure you buy a power supply system that have key connectors. That will help you a lot. That's probably where I see most of the damage coming, is that people disconnect the power cable from the module and not from the busboard. So let's say you're rearranging your case, right? You want to move this module up and this module down, and this one you want to sell, this one you want to install. What people do, they start to disconnect the power cables from the module sides. That's a big mistake. And the reason for that is because the connectors on the modules are oriented in many different directions, and they are not repeated. So when you need to put the connectors back, you start wondering, oh, I don't really remember how was this. This was like this, or was like that, and that is a cause of problem. So rule number one, never disconnect your power cable on the module side. Always do it on the bus side. The second thing is, again, if you have key connectors and you have properly made cables, and that's important, okay? We were talking about the roads and the cars, right? And the transportation, and how a sign can be put in the wrong way. So I've seen modules sold on the market with cables that are actually the notches point in the wrong direction, okay? So if you use a key system, you're using your best knowledge how to connect things, you're doing the right thing, but if the manufacturer provides you a bad cable, then you're in problem. Don't hesitate, trash it, okay? Get proper cables, this is important. Back in the days when Eurorack started, none of the modules had any protection. Over time, as they become like a market, you know, with a lot of more people coming in and more users, manufacturers start adding protections, all kind of protection circuit to their modules to try and help the user avoid a severe damage to the module in case you plug it in reverse. Those protection circuits, some of them provide complete protection no matter what you do, some of them don't. The ones that are less responsive means that if you're going to plug your power cable in reverse, you will short the power bus system, but the module won't be damaged fast. It means if you keep it on reverse for a while, there's an indication that your entire system is maybe flashing or something smells wrong, okay? You would notice it before a severe damage happen. Another level of protection is one that actually has like a little fuse on the module. This fuse can be just a basic resistor that will burn, okay? And then replacing this resistor is not so much of a big deal. You kind of save the module electronics by having just a simple part burning instead of the entire circuitry. Okay, so there's different levels of protection implemented in modules. And then there's the modules that have no protection at all. These are the original, very first modules. Some of them are still in the market, some of them are still made today. There's various reasons why. It's not just because it needs to be redesigned. Sometimes redesigning, adding protection might add some variations to the way the module works. So it's not that simple from the design side, but I would say that probably all modules designed today having some sort of protection. Anyhow, you as a user always need to make sure you understand what you're doing. You need to make sure your power cables are correctly keyed. You better off with busboard that have keyed connectors. And if you don't have keyed connectors, which is fine, you need to make sure that the red line is always facing to the -12 volt pins of the connector. on the bus board.
Ace. Thanks, Kerr. So that's it. If you look in the description for this vidjar, you will find a sort of power connecting checklist that I've written, which will hopefully help just remind you of all the myriad little things that you need to do to make sure you don't get caught out at any point during this process. If you have any input, advice, or nightmare stories of your own, please leave a comment, please subscribe, please support the channel on Patreon, please buy some of my music on Bandcamp, and please don't blow your modules up, mate. Be careful. Be safe. Be well.